great structure for our little colloquium, and I'd like to start, if I may, with Professor Hawking. How did the universe start? With a Big Bang?
We observe that distant galaxies are moving away from us. This means that they must have been closer together in the past. In fact, one can show that all the galaxies must have been on top of each other about 15 billion years ago. This was a real Big Bang, not a puny thing that took place on the stock exchange a couple of years ago. It was the beginning of the universe and of time itself. Anything that happened before the Big Bang could not affect what happened after. So we can neglect events before the Big Bang and say that time began at the Big Bang. After the Big Bang, we believe that the universe expanded in a very rapid, inflationary manner. Again, this inflation in the universe quite puts modern economic inflation in the shade. An increase of billions of percent in a tiny fraction of a second. Of course, that was before the present government. During the inflationary period, the universe borrowed heavily from its gravitational energy to finance the creation of more matter. The result was a triumph for the economics of Keynes. A vigorous and expanding universe filled with material objects. The debt of gravitational energy will not have to be repaid until the end of the universe.
Well, I'd like to stay with this basic proposition for the time being, the Big Bang theory. And to come to you, Carl Sagan, could you help me by putting into layman's terms what was involved with this Big Bang?
Well, here we are on a planet which is about 5,000 million years old. The sun around which it goes is not much older. It is part of a galaxy which is perhaps 10 or 12,000 million years old, which is one of perhaps hundreds of thousands of millions of other galaxies. And none of this, planets, suns, galaxies, was around at the time of the Big Bang. At the time of the Big Bang, there was energy, elementary particles, which slowly evolved into the kind of universe we know today. We are the product of a grand evolutionary sequence, cosmic evolution, about which we are only occasionally aware. One of the great accomplishments of Dr. Hawking is to plug us better in to the knowledge of this long evolutionary sequence.
Well, what I have in my mind is a picture that Carl Sagan had been leading me towards of the whole universe in quite amazingly small packages, like putting the whole world into a matchbox, as it were, immensely dense and immensely tiny. And in fact, so tiny it's kind of disappearing into a little point. Is this the earliest imaginable point that our minds are taking us to so far, Carl Sagan?
Well, as Dr. Hawking said, the galaxies are expanding, running away from each other. The further away they are from each other, the faster they are running away. If you run the cosmic movie back into time, you come to a moment, perhaps 15,000 million years ago, in which all the matter in the universe was touching in, if you like, a point. And a key unanswered and perhaps unanswerable question is, where did all of that matter energy come from? What was before that? And if it was made from nothing, who made it? And who made the maker? And of course, an infinite regress behind that.
Is the universe still expanding fast? I mean, is there a lot more room in space, as I think of it, for the universe to carry on getting bigger?
As far as I know, nothing in the way, and the expansion continues. The question is whether there is sufficient matter in the universe, matter that we have not yet counted, that will slow the expansion down, stop it, and have the expanding universe followed by a collapsing universe, or whether there is not enough matter to stop the expansion, and so the expansion then continues forever. This is an observational question which is still unresolved, and the Hubble Space Telescope, which who knows might be launched next year if we're lucky, might answer this question.
Professor Hawking uses a very striking metaphor of the Earth borrowing its energy from itself. Now, in straight banking terms, that means you're going to be overdrawn, and in the end there's going to be a collapse, a big crunch. So does Big Bang get followed inevitably by Big Crunch?
No, not inevitably. It depends on how much matter there is in the universe, which is a still unsolved issue. I should say that the prevailing opinion is that the universe will continue expanding forever, but that, in my opinion, is by no means a very secure conclusion.
Well, let me bring in the poet amongst us here. Arthur Clarke, you know what T.S. Eliot said, this is the way the world ends, not with a bang but a whimper. When you think of the end of the world, if you think of the end of the world, does it end with a bang or a whimper?
Well, one would like to think that we will end with a bang. Of course, we'll never know. It is rather a long way in the future. Some billions, tens of billions, possibly even much further in the future. And as Carl said, we may have the answers to these questions in a very few years if the Hubble Space Telescope gets successfully into orbit and can peer out to the boundaries of the universe.
If we are sort of living in a little suburb of the galaxy, can you foresee a time when we need to get out of the suburb and colonize somewhere else because of the gradual curve towards the end?
Well, I think the human race, if it survives the next few years, will go on to colonize first the solar system and then to send ships out to the stars and ultimately perhaps to other galaxies. But if the expansion of the universe is fast enough, we will never be able to keep up with it.
Now, one fascinating aspect that is raised is the question of time itself in the book. Now, we all think that we know what time is. It's a relentless march forward. But for the purposes of your argument, Stephen Hawking, you use a mathematical concept that you call imaginary time, which seems to be able to run backwards as well as forwards.
In our theories, there are two kinds of time. There is what is called real time. This is a kind of time that is measured by a clock. The time that we feel passing, the time in which we grow older. Then there is imaginary time. Of course, imaginary time is an idea that science fiction writers, like Arthur, have used in their stories. But imaginary time is also a well-defined mathematical concept. It can be thought of as a direction of time that is at right angles to ordinary, real time, in a certain sense. The universe has a beginning in real time, at the Big Bang. And it may well have an end if it collapses to a big crunch. But in imaginary time, it has no beginning or end. Rather, imaginary time is closed in on itself, like the surface of the Earth. The surface of the Earth doesn't have any beginning or end. I know, because I have been round the world, and I didn't fall off. Individual particles can travel through imaginary time and arrive back at an earlier real time. But I don't believe that people will ever be able to travel back in time, like in the film, Back to the Future.
I'm going to come first, if I may, to you, Carl Sagan, because this idea in Professor Hawking's book, this extraordinary four-dimensional model of the universe with no boundaries, but finite, just like the Earth. This, to me, is really stretching my own capacity for imagination to the utmost. How would you turn it into words for me, a layman?
Well, the first thing I would say is not to feel bad if it's not immediately intuitively obvious. Our ability to understand things instantly, so-called common sense, derives from a certain range of size and speed and duration that are appropriate for human existence. We know about things from a tenth of a millimeter to a few kilometers, from a fraction of a second to a lifetime, and so on. So when we are dealing with matters of quantum physics, where particles have a size of 10 to the minus 13th centimeters, or in cosmology, where we are talking about 10 billion light years or more, it is very reasonable that our intuition is not adequate to the task. One point I'd like to make about this is that every human culture has a set of creation myths, but they're in the realm of mythology or religion or folklore, and they are, of course, all mutually inconsistent. The great thing that is happening in our time is that we are able, through a method which can actually make some progress towards the real universe out there, to find out something about origins, and this is the scientific method applied to the science of cosmology. So I know that's not a direct answer to your question, but I thought it was more important to address the issue of feeling unhappy because it wasn't immediately understandable.
Well, yes, I find that extremely soothing, actually, because it is a kind of sort of formidable task of grasping this. It makes me want to retreat into trivial questions like, is this idea of predicting backwards going to put astrologers out of business?
Nothing will put astrologers out of business.
Well,
alas.
Well, that certainly added a touch of lightness to these tremendous issues that we are discussing: infinity, black holes, and imaginary time. And at this stage, let's